Hello. So this is going to be on the section 7.2, addition and subtraction formulas. Addition and subtraction formulas. So there's a lot of formulas in this section, but the one most important one will be the very first one. And it's proven through geometry. And so first, I do have to convince you of the property between the central angle and the secant line formed by the two endpoints intersecting with the circle. So here if you have a center point and here is your central angle, I'll call it theta 1. Here is this center point, and I'm going to point it in a different direction, forming a central angle. I'll call this guy theta 2. And here would be the two points intersecting with the circle, and if you connect them, you'll form the secant line. You do the same thing over here. And so I'll call this guy the secant line 1, and this guy the secant line 2. And the idea is that if the two central angles are the same, this is theta 2, then the two secant lines are also equal. So if theta 1 is equal to theta 2, then this first secant line is equal to the second secant line. And this is something I think all of you guys can easily accept. Okay, so once you're convinced of that, we're going to prove our very first formula from this section 7.2. Okay, so the setup is actually, I'm going to need a whole new page. Okay, and I'm just going to start deriving. So I'm going to play around with the circle, construct the angles that I need, and see what we get in the very end. Okay? And this is the one identity, one trig identity that will just give you the rest for section 7.2 and 7.3. So the rest would just be a slight modification of this very first one. So this very first one is very important. Okay, so here we have our circle. And I do need to draw the x and y axis. So yeah, I should have done that first. Okay. All right, so here's the setup. The book uses S and T as the two angles, but I'm going to use capital A and capital B. It's just a lot easier to distinguish. So here is my first angle. Let's call that angle A. So this is angle A. Okay. Now so this is a unit circle. So the 1, 1, negative 1, negative 1. So then by definition of sine and cosine, the x value is going to be cosine of A, and the y value is going to be sine of A. Okay. I'm going to do an additional B angle. So if I add a B angle, wherever B is, so let's say this is B, then the position here is really an angle of A plus B. So this point, the x and y coordinate would also be cosine and sine. So for the x, it'll be cosine, but it will be cosine of this whole angle, because this whole angle will give us this position, and this whole angle is A plus B. So this would have to be cosine of A plus B. Okay. So what would be the y value of this point? It would be the sine of this whole angle, and it would be the sine of A plus B. Okay, see that? These are straight lines. Okay. All right. So instead of adding B counterclockwise, what if I instead went B in the other direction, clockwise? So instead, if I go down here for B, a distance of B, so it's really the same angle even though they don't look like it. Again, my drawing is not for scale. So what would be the position for this point? Well, you can still get the position through the cosine and sine function. So it would be cosine of something, and here it will be sine of something. Okay. Well, for this position, remember cosine and sine calls out the angle from the initial side to the terminal side. So in this case, since the initial side to the terminal side is going clockwise, you'll get the angle B, but it's going to be a negative B because we're going clockwise. Okay, even though this angle is a positive B angle, in reference to the initial side, cosine and sine would actually call out the negative B. Okay? All right, so this point is cosine negative B, sine negative B. This point is cosine A, sine A. And then this point up here is going to be cosine A plus B and sine A plus B. All right. So we're going to use the fact that if you have the two central angles being equivalent, then the two secant line formed by the central angle would also be equivalent. And in this case, we do have that. It's slightly hard to see, but here is my first secant line. So if I connect these two guys, you guys notice that the central angle is A plus B, right? Okay. And we're going to do the same thing for these 2 points. And we have the same central angle. It's also A plus B. I think I'm going to use red pen so you guys can see. Okay. All right, so these two lines are the same length. So this line, red line, is equal to the blue line. So blue is equal to red line. So how do we prove it? Well, we have to use the distance formula. So the distance formula of 2 points. So given the first point, x1, y1, the second point, x2, y2, the distance is going to be the square root of the difference of the x. So it'll be x1 minus x2. It doesn't really matter which one comes first because you're going to square it anyways. And next will be y1 minus y2, and that'll be squared. Okay, so that's the distance formula from 2 points, and we do have the 2 points. So if I want to know the length of the red line, I just need to know the location of the 2 endpoints. So here, this first point is going to be 1, 0, because this is on the x-axis. And this second point is the x value cosine of a plus b. The y value is sine of a plus b. So we're going to figure out the red line. And it's going to be equal to, using this distance formula, the square root. And I have to go back to these 2 endpoints and take the difference of the x values. So it doesn't really matter which one you write first. I am going to write the cosine of a plus b, and we're going to subtract that other x value, which is 1. Okay, plus, and we're going to take the difference of the y values. So it'd be sine of a plus b minus 0. So if you minus 0, it is just itself. So sine of a plus b squared. Okay, that's the red line. I'm going to keep it as it is. We're going to clean it up in a bit. But let's go to the other line, which is the blue line, and see what that is equal to. Okay, so the blue line will be the distance formula from these 2 endpoints. So this is the x value, and then here's my y value. Yeah, see that? Okay, and it doesn't really matter which one you write first. I will write, so yeah, let's go cosine A. So top minus bottom, so cosine A minus cosine negative b. Okay, that's a bit of a tight fit. Okay, and then plus the difference of the y values. So it will be sine of a minus sine of the other y value, which is sine negative b. And that whole thing is square. Okay, so everything's underneath the square root. All right, right now it looks like a mess, but we can apply a lot of trig identities to clean up both of these guys. But let's first set them equal to each other because they are equal. The blue line is equal to the red line because they have this equivalent central angle. So if I set them equal to each other, it is going to look pretty nasty, but we get to apply a lot of trig identities to clean them up. So let me list them out first. So recall. First off, we actually know that cosine, what do you know about cosine? Cosine is an even function. So if you have a cosine of negative b, you get to remove that negative for free. But for sine, it is an odd function. So if you have a negative inside, it is equivalent to the negative sine of b. Okay? All right. And then later on, you'll see that I'm going to use a Pythagorean identity in here in a little bit, but we'll apply it once we see it. So let's set the red line distance to be equal to the blue line. So cosine of a plus b minus 1, that whole thing is square. Sine of a plus b, yeah, that whole thing is square. It's equal to square root cosine a, and I get to drop that negative b. So right here, I'm going to apply it right away. It will be cosine of b square. Oh, okay. All right, I'm gonna try to squeeze this in. Okay, so I know that this negative will come out in front. Sine of negative b is the same thing as negative of sine of b. So this negative will come in front, but there's another negative in front. So that will actually make it a positive sine of b square. Okay. All right. You have a square root on the left side of the equation. You have a square root on the right side of the equation. Why not square both sides? And so we get to get rid of the square root. So we didn't even have to bother writing the square root to begin with. And so you can just ignore the square root on the left, ignore the square root on the right, and let's start cleaning it up. So here I'm going to FOIL this one. So if you square something, you guys remember how do you square something? Well, it's not as simple as the first square minus the second square. You have to FOIL it out. So if you FOIL it out, let's see. So if you have something square, so you have x minus y squared. That's the same thing as x minus y, x minus y. So that's really x squared because first times first. Outside times outside is minus xy. Inside times inside, that's another minus xy. Last times last, that's a y squared. So you get this. Okay? So it's not as simple as x squared minus y squared, right? There's something extra, and it's actually a plus y squared. All right. So I'm gonna do that here, and that's going to be cosine square of a plus b, right? We're gonna square it. Minus, and it'll be 2, remember it's 2 times xy. 2 times xy. So in this case, 2 times these two, but it's going to be 1 times that. So 2 cosine of a plus b. And the 1 square, which is plus 1. Okay. And what is this? This is just one term. It's sine of a plus b, right? Sine of the angle a plus b, and that whole thing is squared. So this is just plus sine square of a plus b. That's the left side. Okay. I don't think I have room for the right side, so I'm going to write my equal sign right below, wrap it around, and just write it right here. So for the right side, it will be cosine square of a minus, and it will be 2 cosine a cosine capital B plus cosine square b. And I'm going to do the same thing here. FOIL this guy. What is that? Sine square a, 2 sine a sine b, And the very last term, oh, I have to wrap it around once more. Sine square b. Yeah, you guys see that? Okay, so this whole thing here is the left side. Here's the equal sign. And here's the right side, and I have to wrap it down here for the very last term. But now we can actually apply a lot of trig identities, and this will clean up very nicely. So first off, if you guys notice, here is cosine square of a plus b plus a sine square of the same angle, which is a plus b. And we have this Pythagorean identity where if you have a sine square of an angle plus cosine square of the same angle, it is equal to 1. So this thing here is just going to be a 1. So that's going to be a 1. Let me write the next line in blue. So this will be a 1. Here's another 1. Okay, plus 1. And you have a minus. So everything is going to be the same. So it'll be a minus 2 cosine a plus b plus 1. How about the right side? The right side, we have a cosine square a. Do we have a sine square a? We do. It's right there. So cosine square a plus sine square a is going to be a 1. We have a cosine square b. Do we have a sine square b? Yes, we do. And that is going to be another plus 1. And then the rest, well, it's not a square, so I'm going to leave it as it is. This is a minus, and then that's a plus, so minus 2 cosine a cosine b plus 2 sine a sine b. All right, what's next? Well, you have a 1 plus 1 on the left side. You have a 1 plus 1 on the right side. So that's a 2 on the left and a 2 on the right. You can cancel that out. So if I minus 2 on the left, minus 2 on the right, these 1s would just go away. So you're left with just this term on the left side and these 2 terms on the right side. So let's finish this up. There's a negative 2 cosine a plus b is equal to negative 2 cosine of a cosine of b minus 2 sine of a sine of b. We are very close to getting the very first addition trig formula. And the very last step would be just to divide out this negative 2. So if I divide the left side out by negative 2, I get cosine a plus b. Now here's the right side. If I divide, oh, that's a plus 2. Sorry about that. If I divide out the negative 2 on the right side, this negative 2 will go away, and we're left with just cosine a cosine b. And if I divide this guy by negative 2, well, that will become a minus now. Sine a sine b. Okay. All right, so let me just move this very first trig identity to the next page. So this here, this guy, would give rise to the rest of the trig identities for section 7.2 and section 7.3. Okay, so this guy would do it. So once we start playing around with this one, apply a whole bunch of trig identities on top of this one, you get everything else. So let's begin. Okay. So this is called the addition and subtraction formulas. So the very first one is that if you take cosine of A plus B, this is equivalent to taking cosine of A multiply with cosine of B, but then you minus sine of A, sine of B. Okay, this is called the addition formula for cosine. And our goal is to come up with the subtraction formula for cosine. Addition formula for sine. And subtraction formula for sine. Okay. But we're also going to come up with the tangent as well. Tangent for A plus B. All right, then we'll figure out what tangent of A minus B is. Okay, and it really comes from this single trig identity where we use geometry and a few trig identities to help us out. Okay. So how do I figure out what is cosine of A minus B? Well, subtraction, you can rewrite it as addition. So this cosine, and you'll see, I'm going to do it for a first one. I'll do it for a second one. I don't think we have time to do it for the rest. Maybe I'll do another video, but once you see the trick for a first and a second, you'll figure out the rest. I'll do the tangent, so I'll do these three. Okay, and I'll pick up the pace as we go along. So very first guy, I'll go slow. Cosine of A minus B, you can view this as cosine of A plus negative B, okay? And once you can write it as a sum, you get to use the very first formula. And this is where it gets a little bit tricky because you have to train yourself to see that this B is not the same thing as that B. So when you use a formula, you have to relate what variable is referring to what. So if I want to apply the very first formula to this guy, A is A, but remember, what is this capital B? It is not this B, it is the whole negative B, right? So this A is referring to this guy, the negative B is referring to this B. So if I follow along, those are my A's, and my B's, the negative B would go right here, and it'll go right here. Okay, so it will be cosine of A is A, and then be cosine of B, but it's not going to be this B, it's going to be a negative of this B. Minus sine A is A, and sine of B, well, our B is the negative B, so it'll be sine of negative B. You don't need a parenthesis if it's clearly A being the input of cosine. Here, clearly A is the input of sine. But just to remove any confusion, you put a parenthesis around the input. So this makes it clear that this is cosine of negative B and this is sine of negative B. And if you want, you can, just so everything just looks same, put a parenthesis around that as well. Okay? All right. What's next? Well, cosine of A is just cosine of A, But for cosine of negative b, cosine is even. So we get to use that trig identity again. Cosine being even, you get to remove the negative for free. How about sine of negative b? It is not even, it's odd. So that negative would actually be in front. So sine of negative b is the same thing as negative sine of b. Multiply with another sign with the negative in front, so it's actually going to become a positive in front. Sine of A with sine of B. So what do we have? We get that cosine of A minus B is this. So let's write that in, and I'll write it in blue so you guys can see that we actually derived this. So it'll be cosine of A times cosine of B plus sine of A, sine of B. Okay, and that's it. You just use the very first guy, play around with that sign. So A minus B is the same thing as A plus negative B, and you get to just apply that very first equation. Okay, so that was simple enough, right? This one is a little bit trickier. You can't just change cosine to sine without applying some sort of a trig identity. And we're going to use the cofunction identity. So if you guys recall, the cofunction identity for sine and cosine, if you have, let's say, sine of x, and you want to change it to cosine, then you do have to take, you can use pi half or 90 degree. It doesn't really matter. X can either be degree or radian. So use whichever one you feel the most comfortable with. So maybe it's the degree. So sine of x is the same thing as cosine of 90 degree minus x. Okay. All right. And that means that I can write this sine of A plus B as a cosine now. So what is sine of A plus B? Right? And here you have to identify what is that x. Well, x is the A plus B. So this is going to be cosine of 90 degree minus what? X. Well, my x now is the A plus B, so it's minus the A plus B, but it's minus the whole thing. And so I do need to put a parenthesis or bracket around the whole thing. It's minus the A plus B. So now I've successfully converted sine into a cosine, but just with a different angle, different input. Okay, so this is going to be cosine of 90 degree minus A, but minus B. You see that? Okay. So now that it's in cosine, I get to use the very first two because I've proven the first two. So if I use the very first two, you have to be able to refer back what is that A and what is that B. If I were to use the subtraction. If I use addition, I have to figure out what is my A and what is my B in here. So the plan here is going to be using the second equation, and I'll let you guys look back and forth, try to figure out what is the A and what is the B. The A is not simply just 90 degree. The A is actually going to be the 90 degree minus A. And minus is minus, and then the B is just B. So in this case, B is B. My A here is going to be the 90 minus A. So if I follow along this formula, and it's a pretty long, so I'm going to have to right over here, equal. So cosine of A. But what is my A? It's this whole thing. So cosine of 90 degree minus A. See that? Cosine of A. But this is our A. And cosine of B. Well, our B is just B. Plus sine of A. Our A is not simply A, it's 90 degree minus A. And then sine of B. And that's just sine of B. Okay? All right, and that's it. But now we get to clean this up. Cosine of 90 degree minus A. That looks like an identity that we've written up before. And that's this guy. Cosine of 90 minus x is the same thing as sine of x. So we get to revert that. So cosine of 90 minus A is the same thing as x becomes x, so A becomes sine of A. And this is cosine of B. And here we have another one. Sine of 90 degree minus A. And I'll write that somewhere, but maybe I'll write it down here. So sine of 90 degree minus A is the same thing as cosine of A. So this guy would just be cosine of A, and sine of B is just sine of B. And that's it. So we started with sine of A plus B. We change it to be cosine of 90 minus the A plus B, distribute that negative, and group up the very first two terms to make that the A in the second formula, and B is just the B in the second formula, and apply the second formula, which is the subtraction formula for cosine, with this being A and this being B. And we apply that, and we again use the cofunction identity for this one to rewrite as sine of A, apply the cofunction identity for this one to rewrite as cosine of A, and now we have that sine of A plus B is sine of A cosine of B plus cosine of A sine of B. Okay, so that's sine of A cosine of B plus cosine of A sine of B. All right, so that's the very third one, and you can probably guess what to do with the fourth one. It's the same as this guy. So if I want to know what is A minus B, well, that's A plus negative B, and then use the third formula, right? Okay, so I'll skip that one. I do want to talk about the tangent, and then you can try to figure out how to get this very last one. It's all in your book, but let's figure out what this guy is. Well, tangent of A plus B, let's go back to the basic. We have cosine formulas, we have the sine formula now. So if I can somehow rewrite this tangent as sine and cosine, we get to use all these formulas. So let's rewrite it as sine over cosine. So it's sine of A plus B and cosine of A plus B. Okay. Well, then I get to apply this formula, sine of A plus B, and this formula, cosine of A plus B. And so sine of A plus B is sine of A, cosine of B plus cosine of A, sine of B. And then cosine of A plus B is cosine of A, cosine of b minus sine of a sine of b. And actually, if you want to keep it as an identity, you can. It is equal to each other. This is not what they have in the book. They do a little bit more. They decide to divide everything on top and bottom by cosine A, cosine B, and you'll see what that would do. So the very last step, the very last step here is to divide top and bottom by cosine A, cosine B. Cosine A, cosine B. Why? No good reason in particular, but you can do it because you're doing the same thing on top with the bottom, right? So if I divide, or if I multiply the top by 1 over cosine A, cosine B, then I am multiplying the bottom by 1 over cosine A, cosine B. And this is just balancing out the fraction, so you can go ahead and do that. So very first term, multiply with this, right? It's the whole thing. So first term with that, second term with that, first term with this, second term with this as well. If I multiply sine A, cosine B, and divide that by cosine A, cosine B, the cosine B will cancel, leaving me with sine A over cosine A. If I multiply this with this, you have a cosine A with cosine A, top and bottom. That will cancel, leaving sine B over cosine B. And you can kind of see the reason why now. That will become a tangent A, and this will become a tangent B. Cosine A, cosine B, multiply with 1 over cosine A, cosine B. Well, that's the same thing. So they would all cancel each other out, leaving just a 1, right? Minus, what will cancel out? Is there a sine A down here? No. Is there a sine B down here? No. They have nothing in common. They have everything sine on top, everything cosine on the bottom. Yeah, but what's great is that you can match up the sine with the cosine, the sine A with cosine A, sine B with the cosine B. Yeah, you can separate into two separate fractions, and they all become tangent. So it will just be tangent A plus tangent B over 1 minus tangent A, tangent B, and that's going to be this formula. So it will be tangent A plus tangent B, all divided by 1 minus tangent A, multiply with tangent B. And you can try to figure out how would I go from this to this, and it's the same little trick as going from cosine of A plus B to cosine of A minus B. All right, so that will be all the formulas for section 7.2. I'm going to do another videos where I'm going to select a few homework questions and show you guys how to apply these formulas to solve those homework questions. So I'll see you guys in the next video.